Okay, so today we're going to talk about moles and molar volume. But first, before we start any of that, I want to kind of wrap up the molar ratio that we were talking about the other day. This is a very important video lesson. And so I hope each and every one of you will watch this, and some of you may need to watch it a couple times. Maybe as you're doing the problems, you might have a question, or you might get stuck, and you might need to go back. Okay, so the mole island graphic that I was telling you about the other day, we have mole island here in the middle, we have gram island here, and then of course this is mass. Okay, we have a liter island down here, and this is volume. Okay, and then atoms and molecules. This, of course, is particles. Okay. All right, so there's our three different things, and you see we have these arrows. Think of the arrows as like bridges, okay? So to go from one island to the next, we have to stay on the bridge, okay? We can't swim across because there's all these, these sharks and these whales and all these things that are going to hurt us or whatever, or it's way too far for us to swim. Okay, so we have to take a bridge. And so we have to, if we want to go from particles to mass, we have to go from here to mole island and then up, okay? Or if we want to go from particles to volume, that's fine. We go from particles to mole to volume, okay? Volume to mole to mass, okay? Whatever the case may be, all right? So there's that. Okay, now the next thing I want to talk about is the problems that are on page 339. We're going to do number 42, A, B, and C together, okay? And then we're going to move into molar volume. Molar volume will take me 5 minutes to show you, okay? So real quick. I'm not even sure if it'll take 5 minutes. Okay, so right here is, right here is where we're going to focus for the next few minutes, okay? I will post this to Google Classroom also, but this, as I said, is on page 339 in your textbook, okay? All right. Okay, so number 42A, part A says, okay, so we have 45.6 gram sample of ethanol, C2H5OH. Excuse me. How many carbon atoms does the sample contain? Well, first of all, I want to point out that, okay, so here we have a mass, and they're wanting us to find atoms, okay? Now, they're asking us specifically about the carbon atoms. Before I can figure that, I need to find out how many molecules I have of this, because this is a mass of ethanol, the compound, right? And so I need to go from mass to molecules of the compound, and then I can go from compound to the atoms, okay? So, so let's start with that, okay? So we have, well, first, before we can do anything, we need to find the molecular mass of the compound, okay? And the molecular mass, this is the same thing as if I said the molar mass of, something, okay? But we call this molecular mass because it's a molecule, or we might call it a formula mass. We sometimes say that too, okay? So all those things mean the same thing. Well, I went ahead and I did this for you, and all I did is I took 2 carbons, 6 hydrogens, because I have 5 there and 1 there, okay, and then 1 oxygen. So I did this for you, and this is 46.08 grams, okay? Okay, so now that we have the molecular mass, we're going to take that mass and we're going to change it to molecules of the compound, okay? So, all right. So we have 45.6 grams. We're going to change it to moles first, right? Remember our mole island, okay? Because I don't really have a whole lot of room, well, here, I'll just write it above it. Okay. This is the formula mass, remember? Okay. Then we're going to change this 1 mole of C2H5OH, and we have 6.02 times 10 to the 23rd molecules. Okay. All right, so we do the math, and we end up with 5.96, keeping those 3 sig figs, times 10 to the 23rd molecules of our C2H5OH, okay? So we'll go ahead and box that like that. Now, this is our, actually, I'm going to erase that because this is our right now answer. We're not quite done, though, okay? So I need to kind of move up, though. And there is no more paper down there at the bottom. So I'm going to erase all my keystrokes there. If you need to see that, then you can, of course, pause the video and go back, okay? All right, so I'm going to take that answer, that 5.96 times 10 to the 23rd molecules. And when we look at our ratio of our molecules, if I have 1 mole of my molecules, so if I have 1 mole of this right here, I'm focusing on the, carbon atoms, right? So in every 1 mole of ethanol, I have 2 moles of carbon atoms. I have 6 moles of hydrogen, right? Because I have 5 here and 1 there. So that's 6. And then I have 1 mole of oxygen atoms, okay? For every 1 mole of these ethanol molecules, okay? All right. So if I have 5.96 times 10 to the 23rd molecules, I want to say, and this is C2H5OH, and I want to say 1 molecule. A molecule, don't forget, is a group of covalently bonded atoms. There are 2 carbon atoms. Okay, so I'm going to do that math, and then I'm going to end up with my final answer of 1.19 times 10 to the 24th carbon atoms. Okay, I'm going to do 2 more of these, okay, but I want you to know that there's another example on that, on page 339, okay, there's another example there, and then, but as I said, I'm going to find out, look at how many oxygen atoms there are and how many hydrogen atoms there are, okay? Okay, so now we're going to do part B. Now, part B will be much easier for us because we already have a starting point. We already know how many molecules there are, okay? So I know that there are 5 sorry, I had to change my pen. 5.96 times 10 to the 23rd C2H5OH molecules. And I want to go to see how many hydrogen atoms there are. So I know in one molecule there are 6 hydrogen atoms. Okay. And boop, 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 I do the math, and I end up with 3.58 times 10 to the 24th hydrogen atoms. Okay, and I'm going to box that answer because that is my final. All right, part C. Okay, so part C now, if you look, do you see here what I see? How many oxygen atoms? So there is 1 mole of oxygen atoms in every 1 mole of ethanol molecules. Okay, that also means that there's 1 oxygen atom in every 1 ethanol molecule. Okay, because remember, mole is just a quantity, nothing more, nothing less. Okay, just so you know too, MOL is the abbreviation for mole, MOLE. Okay, so don't think I just forgot how to spell mole or I just keep forgetting the E. That is the abbreviation for mole. It is not the abbreviation for molecule. That is the abbreviation for mole. Okay. Okay, so knowing what I just wrote down here, you will see if we have 5.96 times 10 to the 23rd molecules of ethanol, that means we have 5.96 times 10 to the 23rd oxygen atoms too, correct? Well, yes, but let's show how we get that. Okay, so 5.96 times 10 to the 23rd C2H5OH molecules. And we know in 1 molecule there's 1 oxygen atom. Okay, so the 5.96 times 10 to the 23rd times 1, which is, of course, 5.96 times 10 to the 23rd oxygen atoms. Okay, and we're done. All right. Okay, so now we're going to talk about molar volume. The volume of any gas at STP has a volume of 22.4 liters. Just to remind you, standard temperature and pressure. What this means is it means 0 degrees Celsius and 1 atmosphere. Okay, 0 degrees Celsius, this is standard temperature, and 1 atmosphere, this is standard pressure. Okay, now it does not matter what kind of gas you're talking about. It doesn't matter if you're talking about carbon dioxide, if you're talking about hydrogen gas, if you're talking about oxygen gas, if you're talking about neon, if you're talking about nitrogen. It does not matter. That has a volume of 22.4 liters at STP, okay? And I really like this graphic because it just shows you. So here we have the same volume. Whoops, I'm sorry. I didn't mean to do that. Let me go back. Okay. All right, so it shows you how you have the same volume here. Okay, the same volume. We have the same pressure and we have the same temperature, right? But our mass is very different, okay? So our mass is different, our volume is the exact same. So what does that tell you? You should be thinking a couple things. What relationship do you know about volume and mass? Yeah, exactly. Density, right? Density is mass divided by volume, okay? So if if this is smaller, and if they're all going to have the same volume, then that means it's going to have a lower density, right? Which, if you look at the mass of helium, the mass of helium as compared to nitrogen, and also this is methane, CH4, okay? A large percentage of our room air is nitrogen. A lot of people think it's oxygen, but it's not. It's like 70-something% nitrogen, okay? So now you see why helium balloons float, because look at the mass difference, okay? Nitrogen is, 7 times heavier than helium. And don't forget, nitrogen is diatomic, so that's why it's 28.0 instead of 14. All right? Okay, so I want to go back here. If we had a problem that was, let's say, we have 95.8 grams of, let's say, helium, okay? And we want to know what's the volume, okay? Now remember back to what our mole island picture looks like, okay? So we have 95.8 grams of helium, okay? And we have to change that to moles, right? So we put 1 mole of helium on top, and our molar mass of helium is 4.00 grams. So now I've changed it to moles, right? Because my grams cancel. Now I'm at moles. Is that what I want? No, it's not. I want 1 mole of helium on the bottom, and it has a volume of 22.4 liters, okay? So I do the math, and I end up with 536.48, but I only want 536 liters, 536 liters, okay? Now, always ask yourself, does that seem logical? Well, if you have 95.8 grams, you know that a mole of helium has a mass of 4, okay? So does that seem logical that if we had that large of a quantity that we would have 536 liters? Yeah. I mean, that's a pretty large number of moles, okay? And so, yeah, that, would take up a lot of space, all right? Super, super easy. Volume problems are always the simplest, okay? We would do this exactly the same if, let's say, I said we have 6.91 times 10 to the 24th atoms of, let's say, oxygen, O2 atoms, okay? And we want to know the volume, all right? So first we're going to change that to 1 mole of of O2, 6.02 times 10 to the 23rd. And this is not atoms, this is molecules, right? Because O2 is diatomic, okay? So we'll put molecules there. So this cancels with that. And 1 mole of O2 has a volume of 22.4 liters. Okay, so I'm going to put this over here in the corner because I'm running out of space there. I'm almost done. This is the last thing I'm going to do. Okay, I really appreciate you sticking with me today. Times 22.4. So here we have 257 liters of O2. Excuse me. Let me double check my math there real quick. Okay, 257, that is correct. All right, and then we'll just put a box around that and we'll call that done. All righty. Okay, so let me get to your homework. Okay, so your homework is the packet that I'm going to, well, I mean, it's not a packet. It's 2 pages front and back, but of course it's going to come across or come out on the screen as 4 pages because they're all obviously separate, and since I don't have a hard copy for you. This will not be due until Tuesday, okay? You do not have to send it to me. I will be posting the answer key on Tuesday morning by 8 a.m. And then I'm going to host a Zoom on Tuesday to answer any questions that you may have, okay? I'm not going to talk through each of the problems on Tuesday. I'm just going to post the answer key, and then if you have questions about any of the problems, I want you to plan on coming to the Zoom on Tuesday, okay? And I will start the Zooms at 10 a.m. and we'll just go 10, 11, and then if there's still more questions that need to be answered, I'll do another one at 12, so on and so forth, okay? So, you guys, I mean, you know, you have to put in the time on Tuesday because we will have an assessment on Wednesday, and you're probably thinking, how are you going to quiz this? It's going to be open note, open everything. Yeah, it is, but you have to show your work, and, you know, then you have to be able to come up with the right answer. So, yes, it's, you know, you're going to be able to use everything you have, but I am trusting that you want to do well, and that you know, that you want to learn this stuff because you understand the importance of it, and that we're building on this to go for section 4 and section 5, and then also, of course, chapter 11 really counts on you having a good foundation here. All right. So, again, you can read that post right there. This is the exact post that will also be on Google Classroom too. So, all right. So there's that. You guys have a great weekend, and I hope to see you on the Zoom this afternoon. And then, as I said, the next Tuesday, I will host another Zoom. And then your homework on Monday is just going to be to continue with those problems, okay? So you'll have a check-in form, but you're not going to have any additional homework or anything like that, all right? Okay, thanks. Have a great weekend.